Hello everybody. This will be the first video in probably 2 or 3 part series to cover a bunch of different topics related to the secant line to a curve. Okay, so I start with this one because all the videos that follow are in some way come back to this first initial idea. All right, so we'll start here. This first one will be pretty short, and then there'll be at least one more, maybe 2 videos to cover the rest of it. Anyway, so time for some vocabulary. What is the secant line to a curve? I think I can tell you best in a picture. So imagine that you had a curve. A curve might be given by some function. Y is equal to a function of x, an equation. And this thing in red here that goes through these 2 distant points on that curve is called the secant line to the curve through the points A and B. I just labeled the points A and B, right? But you got a curve, you get 2 distant points, you project the line through them. That's the secant line through the curve. All right, so you're looking at it. That's what the secant line is. And if I can summarize the goal in the early part of the lesson, the first few problems, it will be to just figure out what the slope of the secant line is given the curve and given the 2 points. All right, so in other words, we'll be saying, like, here's the big picture, this is what's going on. How steep is that line? All right, that's what we're going to be after. Okay, so here goes. Take this first problem. Calculate the slope of the secant line to the curve y is equal to x squared through the points -2 for x and then 1 for x. Okay. Now, if you would like to continue to visualize things, then you might say, well, all right, well, here's what the graph of y is equal to x squared looks like. Here's the point where x is equal to -2, and then here's the point where x is equal to 1. And we're trying to figure out the slope of this line right there. There it is. That's the secant line. Okay, so it's like we're trying to figure out how steep is that. There it is in red right there. Okay, so one way you could think about this is, well, look, it's all here in the picture. Let's figure out what this point is where x is -2 for this curve y is equal to x squared. That is the point -2 for x and 4 for y, because -2 squared is 4. And this point where x is equal to 1, that's the point 1 for x and 1 for y. Okay, because 1 squared is 1. So that point and that point are on this line there that's in red. That's the secant line. And what's the slope of it? Well, it's how you find the slope of the secant line is the same way you'd find the slope of any line. The slope of the secant line, okay, that thing in red, is going to be the rise over the run. That's how it's done. So in the way we do that, maybe I'll give you a formula. Remember this formula? I'm sure everybody's seen this one. y2 minus y1 over x2 minus x1. Yeah, you've seen that. Well, that's how you do it. That's rise over run. You subtract the y's, that's the rise. That's the vertical climb or fall on the line. You subtract the x's, that's the run. That's the horizontal movement between the 2 points. You divide them, that's the rise and the run. Okay, that's what slope means. So since I have the points right over here, I could say, well, whichever point you call 1 and 2 doesn't matter. Whether you call this point x1 and y1 or that point x1 and y1, it wouldn't make any difference. You're going to get the same answer. So I'm going to do this. I'll say 4 minus 1, okay? So that's the rise, 4 minus 1, over -2 minus 1, okay? -2 minus 1. Those are the numbers for the formula. So we'll get 3 on top, and we'll get -3 on the bottom. And so the slope of that line there in red, the secant line, is going to be -1. Okay? What's that mean? Well, okay, so on that line there in red, it's falling from left to right. That's the significance of the slope being negative. But it's falling in a way that it's like go down 1 over 1, down 1 over 1. Because remember, slopes rise over run. So it's like the slope is negative 1 over 1. Down 1 over 1, down 1 over 1. Okay? All right, well, it's really, you say that easy. That's what the secant line is. And I know you could find the slope anyway. Probably even before I told you about what a secant line was, you knew how to find the slope of a line. And I guess you could say it's just that. So, okay, let's look at something that, same concept, might be a little bit harder though. What about this one? Calculate the slope of the secant line to the curve y is equal to 1 over root x that goes through the points where x is 1/4 and x is 9. Now we can just like straight away start doing the math if you want to. It's up to you. You know, you can do it however you want to, but you know, I'd say, look, that curve looks something like this, okay? It's got a very steep vertical climb to it around the x-axis, okay? So like if that's it's got a very steep vertical climb about the y-axis, and then it kind of levels out horizontally on the x-axis. Anyway, so if you want some perspective or if you want a sense of the numbers, we could do something like this. Okay, so here's x, here's y. This point where x is 1/4, that'd be, you know, fairly close to the y-axis. Okay, and it's going to be 1/4 for x. And what's the y-coordinate? What's 1 divided by the square root of 1/4? The square root of 1/4 is a half. And 1 divided by a half is 2, so we're going to get 1/4 and 2. And then this other point, now this is not to scale, right? Definitely not to scale, but this other point, 9, that's all, you know, further down to the right. And the coordinates of that point on this curve, see that curve right there? See that bend? That's the curve y is equal to root x, or y is equal to 1 over root x. This point is going to be 9 for x, and then what's a 1 over the square root of 9? That'd be 1 over 3, so 1/3 for y. So there are your points, okay? So I thought I'll put it on there like that and make a prediction about the answer. The slope of the secant line, which I have here in red for you, that's going to be a negative number, right? This line's falling from left to right. My graph might not be to scale, but the relative positions of the points and the general look of the graph is accurate, all right? So, okay, that's my prediction. If I find the slope of the secant line through those points, it's going to be a negative number. Well, let's see, what is it? Now, remember, the slope is just the rise over the run. Doesn't matter the order. I can do 2 minus 1/3 over 1/4 minus 9, or I can do 1/3 minus 2 over 9 minus 1 over 4. Makes no difference. You're getting the same thing. I think let's do 2 minus 1/3. Okay, so this one minus this one over 1/4 minus 9. I just have to be consistent. If I take this y first and minus that one, I need to take this x first and minus that other one. Okay, now I want the exact answer. I know that you could do this on a calculator. But I think, you know, right or wrong, it's nice to be able to do some math on paper. All right, so here goes. 2 minus 1/3, that's going to be 6/3 minus 1/3. So that'll be 5/3 right there. Okay, and 1/4 minus 9, that'll be 1/4 minus 36/4. Okay, so I'll get negative 35 over 4. So those are my calculations. I'm going to get a negative number, right? I knew that. The secant line's right there in red ink, and it is falling from left to right. That means that the slope would be negative. But let's do, so we need to take 5/3 times 4 over 35. Okay, so that's going to be, with some canceling, negative 4 over 21. So that line is not real steep. I don't remember, my picture's not to scale, but the overall look is accurate. But this line, if I had it to scale, like if the whole picture was perfectly to scale, etc., that line would be like you'd go down 4 spaces for every 21 you go to the right. Imagine going down 4 but right 21. That's not very steep. But nonetheless, that's the slope of the secant line. Okay, now, so this is okay as far as it's a matter of learning what the secant line is and doing a little math to show that you understand it. But what's it good for? Does this correspond to anything that is scientific or something like that? Well, the answer I can give you is with this problem. So here in the lesson, I have something like this that has actual data in it. I had made this device that measured the temperature in my garage and sent it to a laptop, and I made a plot out of it. And so if you look in the lesson I posted on Blackboard, there's a plot of temperature versus time that has real data. It's not made up, okay? Every number on there is a actual measurement in my unheated garage, okay? Here, this is just a model of that, all right? So, okay, look at this graph. Temperature on the y-axis in degrees Fahrenheit, time in minutes on the x-axis, okay? So it says this is a plot of temperature versus time in an unheated room on a cold day. Calculate the slope of the secant line through the points that are given and give your units in degrees Fahrenheit per hour. So now that sounds like, for the most part, the other problems that we did, but these are measurements, and then I can find the slope of the secant line, and it will have a meaning to it, all right? With this other problem, the slope is just how steep that line is that goes through those points. It's nothing more, nothing less. Here, if I do that same thing, well, then I have like a meaning to the number, all right? So anyway, well, there's the points. I probably don't need to draw the line for you, but why not? Okay, here's the secant line right through those points, and I will tell you how steep that line is. The slope of that secant line right there. Okay, so you know how to do this. Let's take 62.6, take away 58.3. Okay, and then I gotta take this one, 240 minus 720. Let's get that number, whatever it is. So I'll do my calculations off screen. But 62.6 minus 58.3, and then I divide that by 240 minus 720. So here's the number I get, okay? And well, let's see, let's write down this much. I'm gonna round it on paper, but I really just want to get the number on paper for you. So 0.0089. And then there's more digits, but you know, they're here. I'm not going to worry about writing them down. What are the units though? What were those numbers up there? Those were temperatures. Okay? So that top number was a temperature difference in degrees Fahrenheit. Okay? All right. And then what were these numbers down here? Those were times. That was how much time elapsed between this particular data point and that one. So that was a time, but it was in minutes, all right? So this is in degrees Fahrenheit per minute, all right? Okay. So it's like that as the temperature was falling between these two moments in time, but it was falling in, 0.0089 degrees Fahrenheit per minute on the average. Right? So when I find the slope of the secant line in this example, it's telling me how fast the temperature is falling. There's a meaning to the number, right? For this one, that number doesn't really have that meaning. But when there are units, such as in this example, well, then it means something. All right, that number is how fast the temperature is falling on average between this time and that time. But it says give my units in degrees Fahrenheit per hour. Let's see. I'd have to do something like this to convert it. I need to take 60 minutes per 1 hour. I need to multiply this by a factor of 60 to get it in degrees Fahrenheit per hour. Cancel out the minutes. So, okay, I got my number right here. I'll multiply it times 60, and then I'll get negative 0.5375. Okay, that'll be what we'll report our final answer, negative 0.5375. And whenever we're dealing with measurements, we will always include our units in our work and our answer. And so this is degrees Fahrenheit per hour. So it's negative, meaning the temperature was falling. You can see that. And this is how fast. About half of a degree Fahrenheit per hour. It wasn't falling that fast, but that's how you get from 62.6 degrees Fahrenheit to 58.3 degrees Fahrenheit.